Hello, today we're doing section 5.2, logarithmic functions. The basics. So what's the definition of a logarithm? If b to the x is equal to the y, then log base b of y is equal to x. In other words, log base b of y is the exponent such that b to the x is equal to y. So example 1, calculate the following logarithms. Log base 4 of 4 cubed. So 4 to what power is 4 cubed? Well, 3, because 4 cubed equals 4 cubed. This is a property we'll write later on in the notes, but it's also called the cancellation properties. Logarithms cancel out the base of an exponential. Okay, part B, log base 16 of negative 16. So we're looking for 16 to what power is equal to negative 16. And you might be tempted to say negative 1, but remember 16 to the negative 1 power is 1 over 16, not negative 16. And from graphing, from what we just talked about, 16 to the x, the graph looks like this. And remember, there was something called a horizontal asymptote right here. That means it will never become negative. So 16 to the x is never negative. That means log base 16 of negative 16 is undefined. We can't take the log of a negative. And furthermore, because the horizontal asymptote has 0, you also can't take log of 0. So they're similar to square roots because you can't take the square root of a negative, but they're dissimilar because you can take the square root of 0, but you cannot take the log of 0. Okay, part C, log base 3 of 9. Again, that's 3 to what power equals 9? Well, that's 2. So log base 3 of 9 is 2. Log base 2 of 16 is 2 to what power is equal to 16? Well, 2 to the 4th power equals 16, so log base 2 of 16 is 4. Now the last 4 get a little tricky. Log base 4 of 2. Well, that's saying 4 to what power is equal to 2? That might seem impossible because it's becoming smaller, but don't forget, you can have fractional exponents. What I'm going to do is 4 is the same thing as 2 squared, so this becomes 2 to the 2x is equal to 2, which is to the 1st power. Because the bases are the same, this implies 2x has to equal 1, so x is equal to 1/2. And if we check that, 4 to the 1/2 power is the square root of 4, which is 2. So log base 4 of 2 is 1/2. Log base 27 of 9. That's 27 to the x power is equal to 9. This time, I can't just change the 27 because 27 and 9 can't be written the same. But I can change both of them because 27 is 3 cubed and 9 is 3 squared. So this implies 3x is equal to 2. Divide by 3 and we get x is equal to 2/3. So log base 27 of 9 is 2/3. And these last two really illustrate the property that we can't take the log of a negative number, but we can get a negative answer from a logarithm. So for this log base 5 of 1/25, that's 5 to what power is 1 over 25. And this is where you just need to remember 25 is 5 squared, and 1 over 5 squared is 5 to the negative 2. So 5 to what power is 5 to the negative 2? Negative 2. We get negative 2. 6 to what power is 1 over 216 in order to solve log base 6 of 1 over 216? Well, 216 is 6 cubed, so this is 6 to the negative 3. So log base 6 of 1 over 216 is negative 3. So that is how we can calculate simple logarithms. Now this formula we are going to use quite often. It's the logarithm versus exponential form, and we already used it in the definition. Basically it says b to the x equals y if and only if log base b of y is equal to x. This allows us to solve some basic equations. Example 2, rewrite each equation in exponential form to solve for x. So, part A, log base 3 of x equals 4. To rewrite that, that would be 3 to the 4th power is equal to x, which means 81 equals x. B, log base 16 of x equals negative 1/2. That's the same thing as 16 to the negative 1/2 is equal to x, which is 1 over 16 to the half, which is 1 over the square root of 16, which is 1/4. So x equals 1/4. Now these last two are shows us some unique properties because there's no number here. When there is no number there, we assume it's a 10, and we call it the common logarithm. So now to rewrite it, we get 10 squared equals 4x minus 7. Add 7 to both sides and square the 10, we get 107 equals 4x. Divide by 4, we get 107 over 4 equals x. So that's a common logarithm. And now the natural logarithm, which is ln, and the reason why it's called the natural logarithm is that this appears often when you're talking about population models, bacterial growth, radioactive decay, and all these natural phenomenons, this pops up. But this is equivalent to saying log base e of 2 to the minus x is equal to negative 3. So ln is just shorthand for log base e. So rewrite it, we get e to the negative 3rd equals 2 minus x. Add x to both sides, so we get x plus e to the negative 3rd equals 2. Subtract e to the negative 3, so we get x equals 2 minus e to the negative 3 as our answer. Now we're just going to talk about basic log properties in this class. I've already given you one, and that's that log base b of x is undefined for x less than or equal to 0. That's equivalent to saying the domain is x greater than 0. Another property we have is log base b of b to the x is equal to x. That's our first cancellation property. The b's cancel out. Next property is b to the log base b of x is also equal to x. That's our second cancellation property. Notice how the log base b of x is entirely in the exponent. And last but not least, log base b of 1. We can do this. This is saying b to what power is equal to 1? Well, that means 0 because b to the 0 is 1. So those are our basic log properties. So example 3, we want to use a calculator to compute the following logarithms. So hopefully you can find the ln button on your calculator of the square root of 4 times 6. And you should get approximately 1.5890. Please practice this. And also for part B, you should be able to find the log button. So you can do 1/3 log of 8 minus log of 5. And you should be getting negative 0.3299 approximately. But now for these last two, you won't have buttons on your calculator for them. So what we need to do is the change of base formula. What the change of base formula says is log base b of a is the same thing as log of a over log of b. So for c, that means we need to do log of 17 divided by log of 2. So we do log 17 divided by log of 2. And you get 4.0875. And part D, this would be log of 0.15 divided by log of 8. You should be getting negative 0.9123. I'm pretty sure, yep, that's where I'm going to end this first video.